Hello, and good afternoon. My name is Aaron Creech, and I'm a Senior Application Engineer with Prolim, based out of our Cincinnati campus. My main focus is Siemens Solid Edge MCAD 3D modeling, design for additive manufacturing, P&ID design, and process improvement, as well as Siemens Capital, Vesys, and Solid Edge wiring harness design ECAD portfolio products. Today we'll be looking at Vesys ECAD product exclusively to better understand its power, functionality, and capabilities in efforts to compete and succeed in an ever-growing demand of smart connected products flooding the markets today. After this demonstration, we'll have a quick Q&A session to answer any questions that you may have. I just ask that you save your questions to the end of the demonstration. Now let's get into it. First, let's take a minute to imagine a scenario. You're an engineer responsible for working on one of the harness designs in this awesome truck you see here. After months of long, hard work, it goes into production, and now it's out on the road. You're probably feeling pretty great, right? Let's say a few months later, they are all, 1+ million of them, are then recalled because of an issue that can be traced back to the harness design you were responsible for. Probably not feeling so great anymore. This is obviously a terrible situation for the individual engineers responsible, but also terrible for the company as a whole when you take into account the financial repercussions, the time it takes to resolve the issue, and then the damage to the brand image, right? This is essentially the worst case scenario that can really highlight the importance of getting your designs correct the very first time. So unfortunately, this is one of the potential side effects of a common industry trend. Electrical content is always increasing regardless of the industry or application. This increases the cost to do the initial design as well as the manufacture of the harness, increases the overall design time due to complexity, and similarly, every time something new is added to the design or it needs to be corrected, the chances of inducing an error increases tenfold. With our tools, we attempt to address these issues through the use of automation, collaboration, and verification. The overall goal is to reduce your design costs, design cycles, and risk to avoid these types of disaster scenarios like the ones we just highlighted. So for this presentation, we'll be working with a small tractor design. The wiring and harness designs are partially complete to save on time. So the first step will be to finish off the wiring design. Next, we'll then perform analysis to verify the changes were made. Then we'll synchronize our wiring and harness designs to perform some detailing on the harness. And then finally, we'll utilize some automation to select appropriate parts for our harness and generate a couple of reports. So we'll start by updating the wiring design. First, we have an update. We'll do an update to the style sets. Then, when we'll add the circuitry and connectors for a brake light set, we will then add a multi-core and overbraid to an instrumentation diagram. So let's go ahead and look at this. So now that we're inside of Vesys, we'll go ahead and open up our project. And just a quick rundown of the user interface here. You can only have one project open at a time, but that one project can consist of harnesses and wiring design. So you can see here I've got several wiring schematics inside of this one project. You can have hundreds of these if needed. But for now, we're going to look at the lighting diagram first. Go ahead and double click on that and open it up. And I can initially see right off the bat that there are some visual changes that I want to make to this diagram. So I can do that very easily here in the style sets. And then again, these style sets are going to be, they're going to allow me to kind of change the look and the feel of the design without changing any of the connectivity or recreating anything here. So again, I think looking at this, I see some wire names for each one of the wires. Maybe I don't want to show all of the names for all the wires. So I'm going to go ahead and turn the display off of those guys. Then I'm going to make some color changes to a couple of other elements within the design. So first and foremost, I'll go ahead and change the decoration of the wires to turn the names visible. Invisible. So and I simply just go to the element that I'm looking for and I just turn off the visibility. I'll do the same for the vertical wires. Then I'll go to the graphic properties here. And then as you can see here, I've got a red for the wires here. We're going to go ahead and just change that to a default color. And you can see there's many presets here. we'll go ahead and accept that. And we'll make a few changes to our plug connectors. So right now they're green. As you can see here, again, it's very kind of bright and not visually that appealing to me. I'm going to go ahead and change this color to, again, we have all these default colors here, but at any time we want to do a custom color, we can go into manual, and maybe we'll do like a light purple color there. And then I need to make one more quick change here to the symbol device. Go into the graphics, you can see here it's orange. We'll go ahead and just change that to, we'll do a foreground on this one. Okay, once I've got my changes set, I'll go ahead and apply, hit OK. And I'll go ahead and apply those style sets. And then those changes are made. So as you can see, all the wiring names have disappeared, all of the device connectors are a different color, and even my symbols are a different color now. So now I'll go through and just make a couple of quick little adjustments here. Move some things around. As you can see, it's very easy to kind of navigate around the schematic to get what I need out of it. And now that I got those visual changes made, we'll go ahead and modify some circuitry here. So for this specific design here, we want to copy, we want to create a new lighting system here. So right now we've got warning lights, our front lights, and our middle lights. So we're going to go ahead and just copy this light here, make sure I don't get any unwanted stuff here. And then, you know, like any other software, just do a quick Control-C, and then place the element that I'm copying with a Control-V. And now I have another quick little element here that I can start to create my design. And notice as I'm moving some, I'm going to make some quick changes here, kind of on the whim here. And as you can see, whenever I make a change to maybe relocate or move something, you can notice that the attachment points are always being maintained. So once you connect a wire to a device, that connection will always be maintained. So whether I move the wire or the device, I don't have to worry about accidentally losing that connection point. Those will always be there for me. So next I'm going to go ahead and add a symbol, a quick symbol here. I'm going to look for a switch. So I'm going to move over to my symbols library. Again, these are all components that are included with the software. And I can go through and look at each one of these different libraries that I have here. But I can also use this little search field down here. So I need a switch. And by typing in that switch command, it's going to filter just the folders that have those switches in it. So again, I think there's 4,000 plus parts that come included with the embedded library. So this is going to save me a lot of time and effort having to kind of filter through all these parts just to look for a couple of switches. So I'm going to go to switches here, other, and again, this is only showing me switches, so it's going to save me some time. I'm going to go ahead and just select the single switch, and again, down here at the bottom, I get a quick preview of any of the possible options that I have to select from here. So I'm kind of confirming the part that I'm pulling in before I actually pull it in. So I'll just double click and bring it in. And as you can see, everything's kind of snapped into a grid here. So any kind of element, a device, a symbol, a line, those are all going to be associated to either a minimum or a minor or major grid point. Text, you have more freedom to kind of put it anywhere you want, but the devices, kind of the built-in intelligence of the software, needs to maintain these components and features and elements all onto the grid. So we'll just place that here for now. And now we'll just do a quick connection with a couple of wires to make these connections from my resistor to my switch. And then if I hit W on my keyboard, I can go right back into that wire command and go ahead and complete that wire. And again, because I chose in the style sets to turn those wire names off, again, they do exist. They are in the background. I can turn them on at any time. But as of right now, it's just, since I made that change in the beginning, now every time I create something new, those style sets are kind of maintained. So now that those are in place, we'll go ahead and make a quick adjustment again. So we're going to actually rename some of these things that we've copied over. So for the switch, I can simply double click on the switch itself just to get the name properties, and I can go ahead and change this to brake light switch. Can't spell today. There we go. And we'll name this resistor. Now again, I double clicked here to get that name, but if I right click here and go to properties, I can get some further details here. So we'll go ahead and just change this to R5. And if I double click on the resistor, you can see that it'll actually open up the actual properties of that specific component, resistor in this case. And I'm going to make one quick change here. I'm going to actually go over to the properties here. I'm going to change this value from 0.5. Let's go ahead and change this to 0.2, and this will make sense on down the road here. And I kind of just showed you just as an option a couple of different ways you can rename a device. But let's go ahead and double click this switch here and go back to general. We can see here there is no library part attached, so each symbol can be associated to a library part, say a vendor part number or some supplier information. And maybe for one specific component you have 3 different suppliers. This is where you would kind of differentiate that element. But we'll go ahead in here and just add a symbol or add a library part to the symbol. And because I selected an actual switch symbol and the system recognizes that that's a switch, it's only going to filter the internal part numbers or the library part numbers that are associated to a switch. As you can see here, there's a switch single here. And then maybe I selected a component where there's 50 selections here. So if I type in switch in this field here, you can see that I've got this kind of pretextual input here. So this is the part number I want here, the switch 01011. So once I select that, I'll insert it. It's going to map my pins for me. It's going to just verify that the part that I have, the library part has 2 pins. The brake light switch that I've created, the symbol has 2 pins. So no pins will be added, removed, or renamed. This is kind of just a verification point to make sure you're pulling the right library part for the right symbol. Go ahead and hit OK here. And then it populates all of that information from the library into this individual library component or symbol component. So I'll go ahead and hit OK there. So now that we've got our symbols kind of associated here, we can go to the next step here, and we're going to generate some connectors. So I can go to my Automate tab, and I have this quick little generate connectors button here. And again, you can see it's grayed out at this point because we don't have anything selected. So if I select this brake light, you'll see that now it's active. I can go ahead and generate those connectors, and it automatically generates those connectors for me. So let's go ahead and look at this library part again. So if I go back into this symbol, this is where we input the light switch. But if we go in here and view this library part, sorry, wrong button, and go to the footprint, we can see that it actually pulled the library parts for those pin connectors as well. So the system is intelligent enough to know that, hey, you've got a symbol here. We've associated the library part. There are some connectors that are associated to that specific library part. So it applies those connector library parts automatically, saving you a little bit of time and effort. So go ahead and hit OK here. And again, if we go in and look at these connectors just by double clicking on either one of the connectors, we can see there's that library part that was automatically assigned. And while we're in here, we'll go ahead and change this connector to make it a little bit more useful for us down the road. So once we pass it on to the harness, it'll make a little bit more sense for us. So we'll go ahead and rename these to connectors. So C underscore. No spaces are allowed in this software, by the way. This will be switch. Now you'll notice here that when I selected this individual switch, when I created the generate connectors, it put both connectors on there on either side for me. And this is just a copy of this, so you'll notice that when I go into here, that name will actually carry over as well. So we can, because that's just another instance of that part, then the part name can be the same. We'll go ahead and change the names of the lights that we actually carried over as well. So again, I can either just double click on the tag if I just want access to the name itself, and we'll name this one brake light. This will be the left side. or alternatively, if I double click on the light itself, I can get into the other features here. But let's, I just want to do a quick, so I'll copy this. And what I want you to notice is that when I get into this light and I go ahead and paste that name in there, you can see that this is red. So this system will not allow you to have duplicate features with the same name. So every name on here, again, aside from the connectors that's automatically populated, to kind of help you maintain a correct bill of material, you can never have multiple components with the same name. So we'll just go ahead and turn this to a right, hit OK. And now we've got our correct names from all the features that we've copied over. We've made a modification to the resistor, and then we've created a symbol, created the connecting pins, the connectors, and then added a couple of wires to finish off that portion of the design. So now that we're complete with our design, we can add a note to kind of explain our lighting behavior of our system. So we can do this very easily by going to the Notes tab here. And you can see as of right now, there's nothing here. So I'll just hit the green plus button here, and we'll get into kind of your little notepad thing. And we're going to go ahead and just name this light switch behavior. And again, if I get hit by a bus or something, you know, and I move on, or someone else takes over this project, these notes are going to help me kind of collaborate and let the individuals that are working on this project kind of understand where I'm coming from, as opposed to just sitting there, you know, trying to figure out, you know, hopefully they can figure out what my thinking there was. So these tools just kind of help me communicate and share that information. So we'll do a couple different positions here. For position 1, we'll do all lights are off. Position 2 will be warning lights on. Position 3 will be warning plus our front lights. And position 4 can be front plus warning lights. And then position 5 is kind of still to be determined, so we won't put TBD here. We still are not quite sure how we're going to associate the new brake light that we just created. But for now, we'll just focus on the top 4. So I'll go ahead and hit save here, and that'll add the note you can see here. But kind of one additional thing we can do here, which is nice, is if I scroll to the bottom of the note, you can see I can either edit the text there, and I can also associate the actual elements that will be part of this design, or part of this note. So I'm going to go ahead and highlight the lights that I've got. I'm going to also select the switch, and you can see it's kind of populating those over here on the right. And then I'm going to go ahead and also select the actual schematic that it's on. So I can just click on the lighting schematic and hit OK, and you can see that it actually associates all of those features that are involved in this this note. So at any time, if somebody's not 100% clear exactly what I'm trying to convey here, at any time they can select any of these associated items to kind of understand what parts I'm talking about here. So another little handy little tool to help communicate our design intent. So for this next step here, we're going to actually jump over to our instrumentation design. So I'm just going to double click. And you can see I still have the lighting design open down here in the tab. You can see at any time I can kind of toggle between the ones that I have open. And we're just going to use some automation here to do some quick adds for a couple of features here. So I'm going to create a multi-core. I'm going to just do a quick add shielded multi-core. Select the 2 lines that I want to select, or wires. And now you can see those multi-cores are added. But one really cool thing here is if I go back to the design tab, again, this is going to be all of the objects that currently exist inside of this wiring design. So any elements that are associated in instrumentation, the lighting, the power distribution, or the PTO, those are all kind of highlighting there. But as you can see here, the multi-core has just been added here. So at any time I can select these multi-cores to find out what wires are associated to, where the actual multi-core was. I didn't have to create this multi-core folder. I didn't have to place, I didn't have to manage any of this data. The system is automatically doing all that for me. So next I'll go ahead and use another one of those quick adds, and I'm going to do an overbraid over those same 2 wires. Now, what you can notice here is, again, kind of referring back to this, the minimal management of data and locations of names and stuff or devices. The system is doing this all for me. So as you saw before, we were looking at this multi-core and it lived in this. But once I created an overbraid, you can see that it actually moved all of that relevant information over to the overbraid tab. So again, here's the two wires that are associated. Here's the multi-core, and then here's that overbraid on top of it. So again, saving me a lot of time and effort having to worry about maybe missing or keeping something in the wrong folder. Then when I get to the point where I create the bill of material, it may be listed under the incorrect group or something. So now we're going to go ahead and hand this design over to the team member for analysis to verify that the design is working as intended. So in this portion of the demo, we touch on a few of the features that help boost your productivity. Style sets enable you to quickly update the graphical representation of your diagrams to meet corporate or customer standards. We generate harness connectors, making connector assignments significantly faster and less error-prone by utilizing your parts library. And then we quick add actions simplify the multi-core and overbraid creation. So now that the wiring design has been updated, we need to perform analysis to verify the lighting circuit is behaving as intended. We will assume the role of the team member rather than the original designer to utilize some of the collaboration functionality as well. First, we'll use the qualitative analysis to find the connectivity issues, then record the issues, if there are any, via comments back to the original designer to correct. And then we'll perform a numeric analysis and correct any additional issues that we might find. So now we'll jump back over into our lighting diagram. And so far we've explored the design, the symbols, and the parts tab, but now we will explore the analysis tab. So you have two options here. You have the numeric simulation and the qualitative simulation. So first we'll do a qualitative. And once I have that selected, I can go ahead and run the analysis. Well, it's going to run in the background here, and it's kind of running on my other screen. So we can see here once the simulation is complete, we get this cyan color, the cyan color. The cyan color tells us that there is no current in the design. So if we look a little closer here, let me kind of filter this down here. So I can see that my brake light switch and the PTO switch are both open with no path of ground. So that's to be expected. So let's try to close these and see if we get any luck here, getting some current. Okay, so it looks like we still don't have any current coming here. So this is pretty simple. We can trace back the design to kind of figure out where it might be preventing us from achieving power on this segment. So you can see there's a cross-reference here or off-page reference of the power distribution. So I can either double-click and go into the power distribution tab, but since I know this is kind of the source of of where the power is coming from, I can either right-click on here and go to View Related Item, and that will take me right to the source of the power here. So as we can see here, we do have the green, so that's indicating that we do have power in our design. It's just not going to our lighting diagram as intended. So you can also notice here that the green also kind of indicates the flow of the power as well. So we have some quick identifying features inside of the simulation that can help us here. So if I right click on this ignition switch, double click, gonna hover over the ignition switch, we should get a couple of different options here. So let's see if we can switch this position to, and it looks like that's, that looks like that's probably gonna be our fix. But so we'll switch that over, and now you can see that we have power running back to our instrumentation design, PTO, and our lighting. So again, to toggle back and forth between those offsheet references, I can right-click and go to View Related Item, or if I just click on it and hit X, that'll also take me right back into that offsheet reference. So as you can see now, we do have power going to our system, and it looks like as of right now, power is just going to our new brake light switch. So we'll go through and make couple of quick changes and verifications to check each one of our power distribution options here. Now that we have confirmed that our design is now capable of receiving power, we can continue our analysis. So we're just going to gently or quickly go through the different light select switch positions and kind of verify our note here. So we'll start with position 1, and as intended, it looks like all power is off for all the light switches, or all the lights. So now we can look at position 2. We can see that we're getting warning light power to our warning lights. That is correct. Looks like the flow is in the correct position. Position 3. Looks like, according to our note here, warning plus front lights. It looks like we have 2 power sources going to just the front light. So we may have our first problem there. Let's go ahead and look through position 4. So position 4 looks like we have power going to our warning lights and our middle lights. We should actually have our front and warning lights combined. So it looks like we may have another issue there as well. But let's look at position 5. So again, that's to be determined. So there is no power where we don't need it. So that's good. So let's go ahead and look at position 3 and look at this potential problem we have here. So if we zoom in a little closer, it looks like we have 2 different power sources from these 2 connectors going to the same light here. So it looks like wires going to our front lights, one of which should be going to our warning lights. And let's look at position 4 again a little closer. And then it looks like we have power going to our middle lights and also our warning lights when they should be going to our front lights. So I think the fix here in this case would be to just swap these 2 wires here. So it looks like these 2 wires may be in their incorrect pins. So this is an easy enough change. So we'll go ahead and relay back. We'll create a note here. So if I select the items that I want to, kind of add a note to, I can go to I can right click, go to collaborate, and I can add a comment here. So this comment is it looks as the same as the note does. So we'll go ahead and just put a note back to our designer to say, please switch these 2 wires. And again, because I selected those wires first and then decided to create the note, the system is automatically going to associate those 2 wires for us. So when the designer gets this notification that there's a change request, he can see exactly what 2 wires that I'm speaking about. So now we've communicated a design back to the designer. So now we'll reassume the role as the designer and kind of see what the note is. So I've got a notification that there's been a change request. I open up the design and I can go quickly to the notes or the comments, and I can see please switch these 2 wires, wire 2251 and wire 253. And I acknowledge, oh crap, I made a mistake here. So let's go ahead and change this. So with using some automation, again, we can go back to our Automate tab, and if we select our connector, now we get access to the Manage Connections. So we can actually go in and look at the connections. Here's 253 and 251, so I'm going to just drag 253 down, and that'll actually swap them for me. So I'll hit OK here, and again, because this simulation is always working in the background, anytime I make a change and go back in, you'll see here quickly that simulation automatically updates, or that analysis automatically updates in the background and gives me real-time feedback of how changes are being affected to the flow of the power. So now that I made the change, and it looks like according to the designer's note, position 4 should be front and warning lights. Looks like we've got power to the front and warning lights. So I'll go ahead and go back into the comments. I'm going to reply back to the team member that's doing the analysis, and I'll just tell him that wiring swapped. And I'll go ahead and save. And now that this communication is actually living inside of the design, so I don't have to worry about communications getting lost in emails, or maybe somebody didn't get an email. Anytime anybody opens this design, they're going to have most of the important information right here just inside the design, which will help build the streams of communications for the different team members, your designers and your analysis team members and management per se. So now I'll go ahead and reassume the role of the analysis team member, and I'll go through and let's recycle back through the light switch position. So again, if I go back to my notes here, position 1 should be off. We're good there. Position 2 should be warning lights only. So we got warning lights. We're good there. Position 3 looks like we have our warning and front lights. That is correct by position 3. Position 4 should be front and warning lights. Front and warning lights. Or sorry, front and middle lights. And I'm sorry. There we go. And then position 5 should still kind of maintain no power connectivity. Okay, so it looks like the design is now, has been, at least the current has been verified, and I think we're good there. Now we'll go ahead and switch the type of analysis from the qualitative to the numeric simulation. So I'll go ahead and just reselect, and it's going to go ahead and automatically put me, it's going to go ahead and rerun that simulation, providing some additional information. So the numeric analysis provides additional details that takes into account cross-sectional area and resistance as well. So if I hover over any of these lines, now I can see some additional information. So before I could only see like the possible light switches, but now as you can see, there's a lot more information being kind of shown to me. So this specific wire that we're hovering over, I can see what the rated amperage is, what the max amperage is, what the current is, and as you can see, there's zero current going through here because it's cyan. And then with CSA, you can see the length, the temperature, all that good stuff. So let's go ahead and change this back to position 2, where we know there's some current going through the design. And I'll go ahead and kind of minimize this. No, we don't need that. So I can actually hover over these light switches, and you can see that based on the information of the library part and the assigned symbol, we can see that it identifies it as a light. It knows there, there's the voltage, the current, resistance, and at the bottom there you can see that there's a lit condition and whether or not it's being met. So you can see yes here. So okay, so that seems to be operating okay. So let's go ahead and check position 3 again. Wait for us to update here. And when I hover over the lights again and kind of verify, we can quickly see that even though we have current going to the light, you can see that lit condition is not being met. So the lit condition tells us that not only that it's receiving power, but if they are receiving enough power to function properly. So to investigate this a little closer, if we look at our analysis tab here, again, everything looks to appear to be working, but for some reason that light switch is not. So we can look at down here at the simulation results, and you can see that we have an F3. F3 has blown, so we've blown a fuse here. So again, we're going to want to trace this the power back to kind of review this a little closer, and I'm just going to hit X and go back to this cross-reference here. And I may need to reenact the simulation. Okay, there we go. So there we can see that F3 is yellow. So if we hover over this yellow, we can see it looks like the fuse rating is a 10 amp, and I know from experience that this should have been a 30 amp fuse. We can even see down here at the bottom the suggested rating for this is 35 amp. So let's go ahead and double click this guy. And again, based on previous understanding, I know this should have been a 30 amp fuse. So it looks like maybe the designer has just assigned the wrong part number. So we can go ahead and just delete this incorrect part number. You can see this 10 amp fuse. So we'll go ahead and just delete that. And again, because I selected that fuse device first and then went into the properties, when I go to add a new part, it's only going to show me relative fuses that are relevant to what I've selected here. So I look at the fuse button here, or sorry, look at the fuse and search. Now I can get access to all the different fuses that I have to select from. So I can go ahead and select this 30 amp fuse here, and I'll hit OK. The simulation reruns, and you can see it's still yellow here. So there's still an issue here that fuse is still being blown. So if I double click here, I'm actually going to go into the properties, and it looks like maybe the library part was configured incorrectly. So I'm going to go ahead and change this IMAX from a 5 to a 30. Go ahead and update that, and that should fix our problem. There we go. So now we've got a green fuse there, and we can see that the simulation result shows no issues. So now back into our lighting diagram, we can reevaluate the warning light here. So again, if we hover over the light, we can now see that that lit condition is being met. And same for the front light, we're good there. So we'll go ahead and cycle through just to verify position 4 is operating correctly. So you can see that we are meeting those lighting conditions, but as you can see here, we've got this purple indicator here. So a purple indicator does not indicate failure, but if we hover over the line, we can get a little bit more information. So we can see that the rated and the max, so the rated is 5.09, but you can see that currently it's at 5.4. So it's above and meeting and approaching its maximum level. So it's indicating that maybe you want to change the spec for appropriate power usage. So I'll double click that line, go back into the general tab, and we're going to go ahead and just change the spec from a 0.5 to a 1.5. And that should fix our problem. Again, it'll reevaluate the analysis. It's running in the background. And then as any change that we make, quickly and effortlessly updates for us. So we can kind of maintain any change that we make. It's updating that simulation for us. So now at this point, I think we're pretty much finished with the wiring portion here. So I think now we can go ahead and hand it off to our harness design team to finish off the harness design. So in this portion of the demo, we demonstrated how analysis can be used to achieve better insight into circuits behavior. Analysis also enables you to find and fix issues early in the design process and avoid propagating design errors downstream, where they become more difficult to detect and significantly more costly to correct. We also highlighted some of the collaboration functionality via comments and notes, which is valuable in supporting team-based design environments, allowing you to document important design information within the tool itself, so it's easier to track and enables you to utilize the information interactively via associative cross-probing to make communication even clearer. To propagate our changes that we made from the wiring design to the harness design, we need to synchronize the two. First, we'll update some of the attributes to the new content we added to prepare it for synchronization. Then we'll move the newly added content to the correct location of the harness and make a minor change to the topology. And then finally, we'll update our tables and to display some additional information. So let's go ahead and look at our harness design. I'll just double click this diagram here to open it up. And here we can see that a majority of our connectors have already been placed from a previous synchronization run. But now we have to synchronize again to bring in the recent changes that we made to our wiring design. So first, let's go ahead and notice the primary harness design name here. This is going to come into play in the next few steps. But there's one last step first to perform before synchronization. We have to assign the harness attributes to the brake lights that we copied over. So let's go ahead and go back into the lighting diagram real quick. And actually, I'm going to go ahead and copy this primary harness design. Let's go ahead and double click on the parts that we've already copied over. And if we scroll down, you can see that the harness is already associated to this primary harness, which is our harness design. I'm going to go ahead and copy that. And again, because we copied this middle light down to the brake light, any of those associative elements were brought over with the paste. So again, if I look at the right-hand side, you can see that there's the harness, primary harness is added. And let's see, our three wires that we created though, I think okay, so there's a primary harness there. I think we just stretched that one. But for these three here, I'll go ahead and select these three wires, right click, go to properties. And we can see that our harness is blank. So we'll just go ahead and drop the name in there. We'll do the same thing for the switch. So at this point now we're ready to synchronize our design over to our wiring design over to the harness. So first and foremost, I've got to make sure that I save and close the design that I have open. I'll go ahead and just, for clarity purposes, go ahead and close all these schematics. And now we're just left with the harness design. So I'm going to go ahead and right click on the wiring. You can see now I have the option to synchronize. So I'll go ahead and synchronize. So what this is going to do is it's going to process all those new elements, all those new details, and plop them into our harness design. So it looks like harness design is completed. Looks like there were 0 errors, and total time was 4 seconds. So it didn't take much time to bring those in. So it looks like they're kind of dropped down here in the center. So let's go ahead and move these guys to a more kind of clearer spot so I can see them a little better. And now I'll just go ahead and move these to their appropriate locations. Just a quick move. Place that one there. There we go. And I can move these wire lists around a little bit. So that now my connectors are in place, I can go ahead and modify the topology, and we're going to add a couple of bins to this this section of the harness. So put a little bend here, and you can see my connector moves along with it. And I'll do that same process here as well. So I'll go ahead and rotate them around. So next, let's look at some of the tables in our design. So up here we have a simple from to design here that updates automatically with any changes that we make in the design. So if I go over to the far right, I can see that my new components have been added to this list with the synchronization. So let's go ahead and now modify some part numbers on the wire tables. So if we right click on our wire table here and go to style and edit style, we can actually go in and make some adjustments here. So if we edit, we can select from a number of columns and pre-configured columns. So right now I've got the terminal part numbers selected on, and maybe we wanted the customer wire color in there as well. Go ahead and hit OK, apply. Have that information available in our wire list here. So we can do those one at a time, or we can choose to select all of those at once. That report that we just created. So in this portion of the demo, we showed how simple it is to pass changes between your wiring and harness designs to ensure that they are always in sync with each other. We also highlighted bundle manipulation via grab handles and table customizations via the styling, and then both of which help us keep our design clean and concise, giving you full control over how your harness designs are presented. So now that we have successfully imported our changes from the wiring design, we can now select the appropriate wire cavities and cavity component part numbers for our harness designs and calculate wire lengths. We will do this via automation and the library definition. And then we'll wrap up by generating a bill of material report and then quickly create our own custom. So now before we can start generating reports for our harness design, we'll have to select the appropriate part numbers for our wires and cavity components. And this is a very quick and easy process using automation. So first we'll use the part select under the automate tab. And this is going to pull from our library definitions that selects all the appropriate part numbers for all the wires in our harness design. So if I zoom in here real quick, you can see that each one of these wires, there is no part number associated to them all the way through the list. So we can go ahead and do the wire part numbers, and you can see it automatically populates. It cross-references that library information. It puts in a part number for each one of these specific wires in our design. So, and then next we can actually generate the wire length. So as you can see here as well, there's no lengths brought into this list. So we can actually go to calculate wire multi-core lengths. We'll go ahead and select that automated tool. And now you can see that we have lengths for those elements as well. We can also use automation to select the cavity component part numbers for our connectors. So we can go to select part again, part select, and then cavity connectors. And then I'll actually generate all of the cavity connectors cavities for our connectors as well. So now that we have all of our library parts assigned, we can now generate some reports. So we can do this again very easily if we go to Home tab. Workflow reports. Here we can see some pre-populated reports that we have inside of our inside of the software. So we can do a harness assembly, full bill of material. So let's go ahead and let's do a complete bill of material. Go ahead and view that report. It generates a report for us. It's actually populated it over off the screen here. Let me pull that over. And you can see with just a click of a button, very quick and clean and accurate. Again, this is all generated automatically. I didn't have to manually enter any of this information in. So again, this kind of significantly reducing the possibility for manual errors. So we can see here our part numbers for all of our connectors, our terminals, our wires, some individual part numbers, the description of the parts, the quantity of all the parts, and then the supplier name, so that actual supplier of the part, what their part number is, and the supplier themselves. So we can save these out as an HTML file. We can also print to a PDF file as well, which are two very easy ways to share this information with somebody that may not have the software. And like anything else, you can actually also just copy this text over, Control C, and then dump it into an Excel file if that's what you need to do. And as you can see, there's quite a few pre-configured reports in the system that'll pretty much give you most of the information that you require. And in the off chance if you need to create your own specific report, we can do that pretty simply as well. So we can go into the build feature here. And we just got a quick and easy little application here that we can go in and create a plugin. So we're going to go ahead and just do 4 simple columns here. I just added 4 columns, and each one of these columns is configured. So here I'll pull in the attribute, and I just want to show the name for that one. Say no. So now we're pulling in all the wire names. So for column 2, we'll go ahead and use that same attribute, and this time instead of name, we're going to use let's see here. We need common, and then we'll do name, and then we'll do parts, and then we'll do part number. Done. So now we've got the part number for each one of our parts, and now we'll just do another simple from to. So we'll just pull from, and then to over here. Done. And then we simply rename it to customer ABC report. And go ahead and save that. Oh, sorry, no spaces. I should practice what I preach. Now it's saved, and now anytime we go back to build a report, we can now pull in that. So in this portion of the demo, we showed how automation can be used to streamline part selection, saving additional time and further reducing the risk of errors. We also demonstrated how simply it is to generate reports and customize them to meet your company's needs. Vesys provides functionality that help engineers deliver rapid, first-time right, error-free electrical and harness designs. Through automation, analysis, and a plethora of time-saving features, it allows design teams to put their effort where it counts, in innovating. So now at this time, we'll take any questions or comments you may have. Thanks again.